Hi friends, now I am going to give a presentation on MATLAB self-paced deep learning on Onramp codes. Okay, MATLAB self-paced deep learning Onramp codes is having 5 submodules, namely introduction, then using pre-trained networks, then managing collection of image data, then performing transfer learning, then conclusion. Now in this video I will present first 3 modules. Okay, done. While studying about deep learning, I come across this problem called to recognize this is the deep learning system to detect the dogs and cats. Here you see one dog is there, then after giving the input as a dog, then we get the predicted output as a dog, then the system works properly like that. It is there, it is a hello world program for deep learning system like that. Okay, then okay, in introduction, to familiarize yourself with deep learning, let's see here. Actually, deep learning is a subset of machine learning that uses deep neural networks, that is network with many layers to make predictions. Okay, as shown here. Okay. Okay, then this course focuses on using deep neural networks in MATLAB to perform image recognition tasks. Okay, image recognition system is playing an incredibly large role in the modern life, like driver assistance systems and medical imaging systems that can primarily diagnose the image just like a human specialist like that. Okay. In this course, you classify images with the network that have already been trained on image data. Okay, then you will customize the network for a new application. By the end of the course, you will have a network that classifies the different clouds as shown here. Okay, to do this practical deep learning codes, you don't require heavy theory of mathematics and calculus like that, but you have little bit experience with MATLAB, it is sufficient. Okay, import the image in the file named file01.jpg, okay, into the MATLAB workspace and store it in the variable called image1. The syntax is image1 is equal to im read file 01.jpg. To display the imported image, the syntax is im show image1 in brackets. Okay, to get the multiple images file imported and stored, we use with multiple variables image2 image3, and we show using im show image2 image3 like shown here. In this activity, please open the MATLAB Deep Neural Network Designer. You can see a list of networks that are available for free. You can also use the add-on explorer to add the functionalities that available to you to import and saved using open source format like ONNX, Open Neural Network Exchange like that. Okay. Trained networks have been trained on more than 1 million images to classify the images to hundreds of predetermined categories. Okay, these pre-trained networks have been designed and trained by a team of deep learning researchers, so they have done the hard work for you. Okay, understand? Okay, we see CNN architecture. CNN means convolution neural network. Okay, CNNs are a powerful, commonly used type of neural networks designed for applications where the input has an inherent two-dimensional structure like an image. Okay, all neural networks CNNs are made of layers, and information is passed between those layers. Okay, for a classification problem like this one, the output layer returns the strength of the network predictions for each possible class, like penguin, car, or tree, as shown in figure. A lot more detail to the various kinds of CNN layers, but uh, broadly speaking, the bulk of the network turns the input image into a set of features that the last few layers then use to perform the classification. So how does the network does this? The architecture of the network, that is the type, size and the order of the layers, is chosen by the architect. Okay, however else initially designs the network. Okay, the layers themselves come with many parameters known as weights. The weights determine how the layers behave when data is passed through them. Okay, the value of those weights are determined by the training the network on labeled data. Okay, on this way the behavior of the network is learned from the data. Okay, two networks can have the same architecture but behaves different if they are trained using different data sets. Okay, understand, right? Now we are in the second module, using pre-trained networks. Okay, in that we are seeing the task 1 of classify images. Okay, use the Google Net function to load the pre-trained network, then save the result in the variable called deepnet. Syntax is deepnet is equal to Google Net. Okay, right. Use the classify function with the predicted Google Net network deepnet, okay, to predict the subject of the image stored in the variable image1, and store the network predictions in a variable called predict1. Okay, syntax is predict1 is equal to classify brackets lo deepnet comma image1. Okay, as shown, do for image 2 and 3, predict 2 is equal to classify deepnet comma image 2, predict 3 is equal to classify deepnet comma image 3 in brackets. Okay, extract the layers property of deepnet into a variable called ly. The syntax is ly is equal to deepnet dot layers. Okay, extract the first input layer of the network into a variable called inLayer. The syntax is inLayer is equal to ly of 1. Okay, extract the input size property of the first layer of the network stored in the variable inLayer. Okay, store the result in the variable called in sz. The syntax is sz is equal to inLayer dot input size. Okay, extract the last bracket output layer of the network into a variable called output layer. Okay, syntax is output layer equal to ly of end. Okay, extract the classes property of the last layer of the network stored in the variable out layer. Okay, store the result in the variable called category names. The syntax is category names is equal to outlier dot classes. Okay, investigating predictions. Okay, uh, the classify function gives the class to which the network assigns the highest score. Okay, you can obtain the predicted scores for all the classes by requesting a second output from classify. Okay, the syntax is predict the comma score is equal to classify of net comma image. Okay, create a bar chart of prediction scores. The syntax is bar scores, but note that this bar chart will be difficult to read because there are 1000 prediction scores. You will create a focused bar chart after this task. Okay, create a logical array high scores. Okay, a variable name that has the value 1 of is known as true. Okay, where the scores is greater than 0.01. Okay, the syntax is I score equal to scores greater than 0.01. Okay, use logical indexing to create a bar chart of prediction values that are above the threshold value 0.01. The syntax is bar of scores of high score as shown in task 4. Use the logical indexing that the x labels function to label the bar chart with a appropriate predicted class names. The full list of class names is stored in the variable category names. Okay, the syntax is x labels of category names of high scores. Okay, you see the bar chart on right down. Okay, so far you have been importing each image into memory individually and then using a pre-trained network to classify it. Okay, that's great for one or two, but in practice when you are doing deep learning, you are working with hundreds or even thousands of images. Okay, in that case a better approach is to be used as a data store. Okay, a data store is a MATLAB variable that acts as a reference to a data source, such as a folder of image files, which you create a data store. Okay, MATLAB looks at the files and stores some basic meta information about the data, such as files name and formats, but it doesn't import the data. Instead, you can use the data store to import the data later when you need it. Okay, either individual files or whole data set. Okay, fine. CNNs in MATLAB work shamelessly with image data stores. A network can make predictions on a whole collection of images by providing a data store instead of individual files. Okay, you don't have to import the files yourself, which is the more convenient and also means you don't have to worry about managing your memory. Okay, MATLAB will read the messages as it needs them. Do not You don't need up with 1000 images in your MATLAB workspace. Okay, section you will create a data store and use it with a train the network to predict what is in each image in the collection. Okay, let us see. It is next chapter, create a data store. You can use the image data store function to create a data store in MATLAB, specifying the of folder or file names as the inputs. You can use wildcard characters such as to specify multiple files. Okay, syntax is ds equal to image data store of foo star dot png. This will create a data store to the all png images in the current folder with name starting with foo. Okay, here we use the syntax with variable name imds equal to image data store of file star dot jpg. Okay, next, use the files property of the data store imds to create a file name of the images. Store the result in the variable called fname. The syntax is fname equal to imds.files. Okay, you can manually import data from a data store using the read comma read image and readile functions. Read imports image one at a time in order. Okay, read image imports a single specific image. Okay, readile imports all images into a single cell array with each image in a separate cell. Okay, I is equal to image read image ds comma n syntax. Okay, in our case image equal to read image imds comma 7, the syntax is. Okay, okay, you can use an image data store in place of an individual image in CNN functions such as classify. The syntax is prits equal to classify of net comma ds. Okay, in our case we use the google net loaded as variable net to classify the contents of all the images in the data set. Store the result in the variable called prits. Okay, and note that the classify function will be running 12 images through google net. It maybe take a few seconds to execute. Okay, the syntax is prits equal to classify of nets comma imds. Okay, okay, you might have noticed that all the images you have worked with so far have been square images, and maybe have noticed that they are all are same size. Okay, to use images with an existing network, they need to match the expected input size for the network. The variation depending on the network, but most predicted networks accept a square color image around 220 pixel height by 220 pixel width. But what if your image are different size and your data set collections grayscale images? Then cropping and resizing and converting is required. Okay, and this is the next chapter, adjust input images. Okay, use the size function to view the size of the image img. Save the result in the variable called sz. The syntax is sz equal to size of img. Okay, The input layer of the network specifies the image size that the network requires. Expected size equal to input layer dot input size. Okay. uh, the in our case, import Google Net and extract the input size property of the first layer of the network, then store the result in the variable called insz. Okay, the syntax equal to net equal to Google Net, in layer equal to net dot layers of 1, in sz equal to in layer dot input sz. Okay, you can use the im resize function to resize the image to match the expected input size. Im resz is equal to im resize of image of number of rows and number of columns. Okay, as shown. Okay, then use the im resize function to resize the image stored in the variable img to be 224 by 224. Then store the result back in the variable img. Okay, the syntax is img is equal to im resize of image comma 224 comma 224 of. Okay, then im show of image. Okay. Okay, then next chapter, resize images in data store. Okay, recall that you can use the image data store function to create a data store. You can use wildcard characters such as star to specific multiple files. ds is equal to image data store of star dot jpg. Okay, then in our task, create an image data store named imds that refers to the image file with the extract extension .jpg in the current folder. imds, the syntax is imds is equal to image data store of file star jpg. Okay. Okay, an augmented image data store can perform simple pre-processing on an entire collection of images. To create this data store, use the augmented image data store function using your network's image input size as input. AUDS is equal to augmented image data store of rows comma columns comma imds. Okay, in our task, create an augmented image data store from imds that will resize the images to 2024 by 224. Name the data store has auds. Okay, the syntax is auds equal to augmented image data store of 224 220 rows 224 columns comma imds as shown. Okay, you can use the augmented image data store as input to the classify function. Before each image is classified, it will be pre-processed using the methods that you are specified when you created a data store. Okay, in our task, classify the images in auds using the classify function using the network stored in the variables net. Store the predictions in the variable preds. Preds equal to, syntax is preds equal to classify net comma auds. Okay, converting to RGB images. A grayscale image is sized n by m by 1. Many pre-trained networks like Google Net requires image sized p by p by 3. If your image is grayscale, you need to convert them to a 3D array to use them with Google Net. Okay. The images you will use in this activity are grayscale. You can use the montage function to display all the images. Okay, our task is use the function montage to display the images in the data store IMDS. The syntax is montage of IMDS. Okay, you can convert these images to a 3D array by setting the color preprocessing option when you create an augmented image data store. AUDS equal to augmented image data store n comma m comma imds comma in inverted commas color preprocessing comma and then grade 2 RGB in inverted commas. Okay. uh, then this will repeat the grayscale image 3 times to create a 3D array. If image RAY is a matrix that represents a grayscale image, the processed image will be a 3D array that represents a color RGB image. Okay. uh, in our syntax, AUDS equal to augmented image data store comma 224 comma 224 IMDS comma inverted commas color preprocessing comma inverted commas grade 2 RGB is used to create uh, RGB images from grayscale images. Okay. Okay. Then in task 3, classify the images in AUDS using the classify function. Google Net is stored in the variable net, then store the predictions in the variable preds. The syntax is preds equal to classify net comma AUDS. Okay. Okay. By default, image data store looks for image files within the given folder. You can use the include subfolders option to look for images within the subfolders of the given folder. DS equal to image data store of folder comma inverted commas include subfolders comma true. Okay. In our task, create the data store FL or DS to all the images in the subfolders of the flowers folder. The syntax is FLWRDS equal to image data store flowers comma include subfolder comma true. Okay. These images are not constantly sized, so recall that to classify these images with Google Net. Okay, you need to resize them first. Okay, our task is create an augmented image data store from FLWRDS that will resize the image to 224 by 224. Name the new data store has resides. Okay, the syntax is resides equal to augmented image data store of 224 224 rows 224 columns comma FLWRDS. Okay, done. Okay, then use Google LeNet loaded as an variable net to classify the contents of all the images in the data set. Store the result in the variable called prits. Note that classify function will be running 15 images through the Google Net. It may take a few seconds to execute. Okay, uh, our syntax is prits equal to classify net comma resides. Okay, done. Finally, the conclusion is out of 5 modules in deep learning Onramp course, 3 modules are completed. There are introduction, using pre-trained networks, managing collections of image data, and performing transfer learning, and conclusion we see in the next video. Thank you.